On the video.
Hey, hi, like a representative from Eduving side, could you please add me as a co-host? Like I could not able to share my screen. So could you please ensure my screen is visible through the chat?
Yes, it's visible. It's visible, sir.
Yes, yes.
Yes,
Thank
sir.
you. We'll go ahead. So good evening. So here we are just continuing the last topic which was being done, like strength of materials one. Last topic we had done with our NDT non-destructive testing. In this particular session, we'll be looking only with the uh, destructive testing. Okay. So in non-destructive testing, we would be like without making any of the changes in the material or else any deformation or else like a crack or dent. Without that, we are going to test the what is the hardness of that and strength of the material. But in destructive testing, it is totally entirely opposite to that of non-destructive testings, whereas we will be destructing or else like we would be deforming some other materials in order to know the strength or particular hardness of the particular material. So last time we had seen around six types in non-destructive testing. Right now we'll be looking on to 6 to 8 types in the non-destructive testing, whereas you still have like 13 to 14 types are there, which is there, but these are the six types which has been commonly used right now. So yes, I just wanted to have a quick recap of last session. Then we'll be going ahead with the destructive testing, whatever we have seen. So just wanted to distinguish between stress and strain. So stress is the internal force. Whatever the force you are applying onto the particular object is called as a stress, and what is the particular area which is going to deform because you have applied the force onto that is called as a strain. Just remember these 2 points, whereas a stress and strain. Stress is something that the amount of force, whatever you are giving, acting on the particular object is called as a stress, and what is the amount of area which is going to deform out of the force what you have applied is called as a strain. So in the last session, we would have discussed about tension, compression, shear, bending, and torsion. So this is the normal things, but still we have like fatigue, bend over, and bearings. We have all those things, but these are the five main things which we'll be using, like tension, compression, shear, bending, and torsion. So tension is nothing but what are the material you are going to take, like maybe a iron rod if you are going to take ahead with the iron rod or else your rubber eraser, whatever it is. I wanted to whatever the material whichever is there applied to in the world applies for the strength of materials. We can able to test with the strength of materials. Like if in the case of wood, if you're going to put on any other furnitures using the wood, you can just go ahead with like whether this wood is going to withstand all this weight, whatever I'm going to sit. Like 3 to 4 people are going to sit on the particular furniture, particular sofa. Whether this weight is going to withstand that. Whether my material, whatever the wood I'm going to use, is going to withstand that, because right now the whomever is in the furniture field they knows that to use the teak wood or this wood that wood, but when it comes to materials it is like particular. If you in the case of like steel, in the case if you're going to take like a steel or iron can be used as our building your materials, building your home, or else it can be used under the tables as well. But it can be used, even it can be used to hold the bridges as well. Like the cables have been used to hold the bridges. So the material, the same iron, whatever I'm using on the tables, I cannot able to use the same iron for the cables which is being used on the bridges. So the same iron material is same, but for the uses, for the usage or for the applications, it is going to differentiate whether it can be of composition or any other mixes. So tension is nothing but so tension, you are going to pull out the object, pull out an particular material from both of your ends is called as an tension, whereas pulling is something called as a tension, whereas compressing is nothing but pushing your material from both of the ends is called as a compression. Whether you can take it out vertically or also horizontally, whatever the object, which whether it can be a ball, smaller ball like football, whatever it is. Tension is nothing but pulling out an object, and compression is pressing the object. So shear is nothing but your tearing of objects, tearing of paper, your scissor, it is going to deform out of a shape, whereas it can be reclaimed to be on the original shape as well. Bending is nothing but so compression and tension will act on the same place is called as an bending, whereas your both the ends, top and bottom end, will acquire an tension, whereas in the mid end it will be of your compression end. So even that one place can be of when you go ahead with the bending, the one place instead of going ahead with the top and bottom, you can just go ahead with one place if you're fixed to one, other place you can just have an impression or as a force which is being acted on the other end. So torsion is nothing but twisting of an object. So your screws, your drill bits, what you're constructing rods, iron rods, which are also a torsion material. So just for the recap of the last session. So now we'll be going ahead with the introduction. So distributed testing is nothing but loading a material or else applying some force onto the material to know the hardness of the material. Like it can be deformed or else unless or until it is going to even break away. Break away is nothing but your failure occurs. If I'm going to bend my plastic scale, it is going to break on a particular time period, particular forces has been applied. So that is where called as that my particular scale has that much of uh, liability, whereas I could able to force that I able to apply onto it. So determine the mechanical properties. Manufacturing differs. So if I'm going to have that one particular piece, so instead of in NDT, we'll be looking on where the crack has been occurred and where is the places which is not been properly made, properly manufactured. But in this, we'll be looking ahead in the distributive testing. We'll be looking ahead with whether the particular proper made, sorry, a product is being made and whether it is going to withstand the particular force or not. I'm going to test on to that. So when you could not able to do distributive testing is that when you have the only one specimen, like only you have the only one test piece, whereas you could not able to like you have the particular piece like Eiffel Tower piece, you have it over there in the museum. I could not able to do the distributive testing over there. Like I wanted to, it is built on 1700, so I wanted to test what and all materials, how much it could able to withstand the force. So I could not able to take that material to undo destruct that. In particular times, we could able to use non-destructive testing. In other times, we can use destructive testing as well. So here we have the seven main types, seven main tests. We'll be looking ahead with the further session. So tensile, compression, bend. So these three things will be done on a single machine, single test. It can be done. And then your impact test, fatigue test, hardness test. Hardness test, the particular hardness test, you'll be having a three types. And then with your creep test. A tensile test is nothing but you are going to pull the here we will be acquiring that material or specimen. Maximum will be using material itself. So that will be easy for your understanding. So pulling the material until it breaks, or else compressing your material until it breaks, or else you're bent. So three is a common thing. This three can be done on the same machines. So impact test. So suddenly you are going to give an impact on the particular material. That may be your shock absorber or else your spring, whatever it is, like even an object. If a particular force not being slowly is being applied, it is when it is being suddenly applied to a particular object, how much it is going to deform or whether it is going to get braked or something else is called as your impact test. When it comes to your fatigue test, your both your compression and tensile will happen on the particular material, like for the period of time. Like per second, 25 times your tensile and your compression happens on the particular material in order to know whether it is going to withstand your fatigue. Harness is nothing but we will be having putting a dent on the particular material in order to know how much hardness is going to get onto it. So creep test, whenever you are going ahead with the bridges, you will be having the suspension cables, and as well as your bridge will be moving ahead, like expanded, as I said in the last class as well. Your bridges will be expanding as per the climate things. So for that, you are putting your material on the particular temperature with the tensile. You're going to pull that material, and with the particular heat is being applied on the particular material, and then it is you are going to test that material, how much load it is going to get withstand. So quickly, we are just going to test missions. These are the missions used right now. So far, it has been used right now. So tensile compression bend, as I said, for this three test also we will be using universal testing machine. So I'll tell you how does it works and what is going to create an impact, how the particular material is going to be. You are going to find out whether that particular material is how you are going to find out the tensile impact. You'll be having two methods, Charpy and ISOT method. Charpy is different and ISOT is different. And fatigue testing machine for hardness we'll be using as of now whenever for the study purpose. If you are going ahead with lab like college labs or academic labs, you'll be having Brindle harness, Rockwell harness, and Vickers harness. But right now, all the three is going to the same, only that indentation material differs. So creep is creep testing machine. So your universal testing machine looks like this. So on the bottom, you'll be having a rigid, which is not a movable thing, which is a fixed one. So on top of that sample holder, either you can place your specimen or your material in the horizontal way or else in your vertical way, in which how we wanted to measure it. So from the top, this is a moving stroke, which is also called as your crosshead. Crosshead is being pushed using your pneumatic hydraulic system, which has been up and down bottom things will be there. So this is for your compression, to know your compression. If in the case of like tensile, if you wanted to go ahead with your tensile thing, the holder will be there applied onto the specimen. So this moving stroke will be moving upward in order to pull your material. So it's nothing but prepare your specimen as per your ISTM or ISO standard. So if you wanted to go ahead with your bridges, suspension cables, or else like your table material, whatever you require, those things has an particular standards, and you have to build the specimen as per the ASTM or ISO standard. So mount the specimen and select the test speed rate. Test speed rate is nothing but the standard used to validate the results. So test speed rate can be updated, and crosshead speed, like per second, I want to move my crosshead. I want to give my pressure gradually. So 2 mm per second, or else like 5 mm per second. Also like 2 mm per 10 seconds. I wanted to give it gradually. So it is a lesser tension I'm going to give on to the tensions. You can be able to change your crosshead speed as well. So pull or make it as a tensile, or else you compress your particular material till it breaks or it get cracks. So it will be recorded on the system. So this is our output, how your output looks like. So your O to A point, this is your graph or your point which will be getting, you'll be getting it as an output. So your O to A point will be proportional. It is directly proportional to your stress and strain. Whereas your stress is nothing but how much pressure you are going to apply, how much force you are going to apply, and strain is how much the particular object is getting deformed, is called as your strain, as said earlier. So on your O to A point, you'll be having a particular pressure, so it is also going to get deformed, and your A to B point is nothing but it is getting your high yield point. It is your A to B point is called as an high yield, and B to C point is called as a low yield. Whereas it permanently it starts to get stretched forever. Like from O to A point, if you're going to stretch or if you're going to compress a particular material, it will come back to its normal position. But when it comes to your A to C or B to C point, when your expansion has happened, it is not going to get back to its same place. And C to D, my total C to D is nothing but your it has attained the maximum elasticity, whereas the particular material could able to get it. And D2E is called as your necking. Whereas this is a normal size of an normal size or with diameter of a particular object. Whereas when it is being pulled it, when it goes under the tensile strength, your material goes deforming over there, and even that could able to apply it for a particular point. After particular point of necking, your material gets breaks over there, or else uh, your machine sheds over there at the point. So Charpy and ISOD impact test. Sharpie is using this is how your Charpy and ISOD machine is same, but only the thing which changes is that your striking edge will get changed. Striking edge for Charpy, it will be on the notch edge. This is your notch. This is called as your notch. Your striker will be looking like this. And for striker for ISOD test, your this is going to get impacted on your material. And when it comes to your striker end, this part will get to your material so that it is going to have a dent same like this. So you are going to find out how much the place which has got dented, so that much amount that could able to withstand for the hardness. So Charpy and ISOD is nothing but so for Charpy it is placed on the horizontal portion, ISOD is placed on the vertical end. So, and the Charpies, you can mount it on the both the ends, and whereas for ISOD, only the bottom end or the top end will be placed or clamped over there. So it is same like a normal pendulum, how we used to have in the clock, our older antique clocks, how we used to have the same like pendulum. It will be meant over there, and this pendulum is being made on the 90-degree angle, and it is being kept over at the point, and it is being locked at the moment, and then your material is being kept at the bottom, and the pendulum is being released onto that point. Once the pendulum has been released, it is going to strike onto your material and is going to make a dent on your material. And therefore, how come you are getting the result in the sense you have the friction pointer over there on the top. So how much and what force did your pendulum has crossed before touching your material? What is the force that pendulum has come down, and after has touching how much force it is going to get occurred? That is what it is called as observed energy equal to initial pendulum energy minus your remaining energy. So fatigue, the same thing as I said, like your compression and your tension will happen on the same time with the particular number of cycles to till the moment it is going to get breaked or deformed. You are going to repeat the test. You can just take it as how many minutes does it takes to get deformed or break, or else like you can just also take it as how much cycles it is going to get through to break a material. So this is your specimen which is being placed in between. So this is like a spring which will be acting on the to and fro motion, front and back motion. So it has been that particular pressure will be acting on top of the material until it is getting deformed. So as I said earlier, Brenner's Rockwell, because if you wanted to go ahead with a separate machines, that's absolutely fine. But nowadays in QA, quality assurance or quality control team, they are using the modern universal hardness tester, whereas you just wanted to change the intended ball at the bottom, whereas it changes. Like Brenner is nothing but you will be having a ball at the bottom. Rockwell is your diamond shape. Diamond cone will be there, and because his diamond shape will be there on the bottom. So I'll just let you know. So once after placing your specimen on top of the anvil. So you'll just rotate this rotatory wheel. So it goes on the top, lifting screw will goes on the top, and it will be near to that intended. So with a particular load, whatever you wanted, whatever the client is looking out for you, the particular load, you can just give the particular load will be there, like 25, 50, 100 Newton. That load will be there on the back. So how much of the load you wanted to fix, you can just put the screw on that. You can fix the load, and you can that ball when you release that uh, load, that load the whole force is going to get acted on your intender, and it is going to give a dent like form on this same like this. It is going to give you a dent like on the top of the material. So for Brinell, it is you'll be in the ball. This ball shape is called as an your indenter. For indenter, diameter for Brinell, diameter has been measured. So like how many diameters, what is the diameter thickness of the things, it has been gone inside. And Rockwell is nothing but your depth, how much depth it has been gone inside, and Vickers is nothing but diagonal lengths it has been measured. For your hardness testing, you can just use whatever the materials you require, but for the maximum, you could not, you preferably the things like rubber materials, plastic materials, you could not able to use it because as they have the highest elasticity, it will be getting returned back to the same position when the once the intender is being taken out of it. So this is preferably looked for your steel, iron, or metal items. Your creep testing machine. So this is how your creep testing machine will be there. So your material will be placed on the mid and it will be given with a particular load on the loading baits. So how much ever the you load you require, you can just place it on the load depending upon the material, whatever you are placing it over there. So it will be pulled like it will be on the tensile force, whereas in the outer area your furnace will be there. So it has been explained on this image. So your furnace will be giving a appropriate heat. Like if in the case of melting point is 1100, it will be just giving you like 800 or 700 degrees Celsius. That will not make your particular material to get melted, or else it won't be like too low to get the heat. So your constant force is getting applied onto that material, and then your furnace outside layer it will be heating your material whatever you are using inside, and it is going to till the moment it is going to get breakthrough. You are just going to look into that how long the time it is going to withstand that particular heat on that particular force which has been loaded. The same thing, working model, prepare the specimen, model the specimen, and heat is being applied and apply the constant load. So measure the deformation over the time. So what is the time that took to deform to break through it? So continue until the specified test duration is reached or the specimen touches. So if you wanted like a particular time, also you can just load it for you can just load it for 5 to 10 minutes. Or like I wanted for 120 seconds, and since that is also fair good enough. Or else if in the case of like I wanted to go ahead with till the material it is getting breaked. I was just wanted to go ahead with that in sense that would also fine. And for all those tests, you'll be going ahead only with the ASTM approved standards, or else your ISO approved standards material has to be used in all of your tests. Yes, I am done with my part. So I'm done with my part. So if you have any clarifications, doubts, or else you just wanted to add up something onto it, or you wanted to question against it.
Yeah. So my name is Rakesh. So I
Hello,
want to know
Rakesh.
about the hardness test you explained. You mentioned that only something like a very hard material like iron or something like that. But as I know that we do the
Mm.
test on the rubber kind of things also. It's also important to do the test on the rubbery product, right? Which is have a more
Uh,
elasticity. Yeah.
Yeah, for rubber products, you can use. That's what I said. It is not preferable that much for your hardness test because your as your rubber has a more elasticity. Whether the material, whatever you're using on top of the cables or wires, it has some elasticity. So once you put a
Yeah.
dent on the top of that, also it is going to. You're not going to punch a hole. If in the case of like punching a hole, it has got deformed. But if in the case of like rubber materials, it is not preferred to use this hardness tester, because again that might if in the case of like you're going to have a dent of 0.25 on the particular when the particular force has been applied, once after you take out the indenter out of the material, again that might go to 0.22. That might have your tolerance level as well.
Yeah, so
It might.
so
Mm.
yeah, so there is two kinds of hardness test for the SOAR A and SOAR D. Can you please explain more about that? Because I always get confused.
What do you want it to be? Two types of.
Like there is a hardness test called SOAR A hardness and SOAR D hardness, right? One of them
Uh,
were for the rubbery
that
kind of thing.
we'll be using on Rockwell, whereas even the ball can be used, and then your indentation depth of mm, your diamond cone can also be used. That depends upon your material.
Okay, okay. And I want to know more about the creep test. Why it's important, and is it important? It's only for the high temperature, like only for the metals, nothing something for other things, like as you said that we test the bridges, like the creep resistant of any bridges. Like,
Okay.
so what we do on the bridges as a creep test?
So creep test, it is actually material is given the load on a particular material, and it is being heated for the particular time. So it can be taken for your tungsten, whereas you have it on your bulb or as your focus lamps, higher luminous it gives. So for that
What is,
particular things,
I'm
uh,
still confused about the creep test. What is creep test actually?
is that's what Rakesh, your creep test. You wanted to explain the creep test, or else you wanted to
Yeah, please,
more
please, one
applications?
more time. Yeah, what is the creep test and why it's important?
Okay, why it is also important, you want to know.
Yeah.
So in the case of like jet turbines, whenever you are go ahead with your aircraft engines, interior
Mm-hmm.
you will be having your combustion chamber, everything will be there inside your engine, aircraft engine or else your vehicle engine. But the material outside which is being used, it's a cast, it is called as a cast iron normally. When it comes to your four-wheeler or two-wheeler vehicle, your cast iron will be placed outside to the engine.
Mm-hmm.
Okay, so that time you wanted to know how much heat, with whether it is going to get withstand for that, because obviously interior your combustion is going to happen. Your particular object, your piston is going to get heated inside it,
Mm-hmm.
and your oil flow, whatever the oil flow is happening inside, everything is going to happen inside that cast iron. So you wanted to know how much heat or temperature, whether this particular material is going to get withstand. This, in the case of
Okay.
like two-wheeler or four-wheeler, we can use a cast iron. But if in the case of when it comes to your aircraft, you cannot able to use a cast iron, because as it has a more weight, you cannot able to use a cast iron. All the materials will be of yours, like sheet metal or else your aluminum part.
Mm.
So
So
in
it's more
such
about
kind,
the heat resistant.
yes, about your aerospace, your turbines, your engines. So how much heat is going to you are going to get withstand for the particular material matters that now.
Okay. And there was one more term in tensile strength was the plastic behavior. What is the plastic behavior?
Where it is on the
It was in the tensile test, probably.
tensile.
Yeah,
In the
Okay,
graph, you can see.
there was a graph. Yeah,
graph. Okay,
yeah, yeah.
okay. Plastic behavior is nothing but your it starts to get. You are not going to apply any heat over there, or else it is not going to get melted. But still, it gets the behavior or the characteristic of your plastics. like same like this, how you are going to pull the metal out of an object, like with the particular Newton meter, if you're going to give a force, you are going to pull an object over there, whereas it starts to get melted on the particular place, which is called as a necking, where you can see it over here. Like all the place, 1 second. Like whatever it is, this is straight. This is the like actual diameter which has been mentioned over there. Like it may be
Mm-hmm.
of 2.5 mm or whatsoever. But if you could able to see here, your material's diameter is got thin.
Of
So
course,
compare,
it's getting pulled. Yeah.
yeah, when it getting pulled, so this particular place when it started to get melt, because you're not going to apply any of the heat also over here. When you're going to pull it, this particular place, only this particular place is going to get your deformed place. So that period of time is called as your plastic behavior. Like, okay, this is the maximum strength that material could able to withstand. Again, if you're going to pull something after D, your material is going to get down to break or to crack.
Yeah. Okay. Mm-hmm. Okay. That's good. Thank you.
Thank you. Any more clarifications on the chat box? So if there is no clarifications or doubts to be asked from your end, so we'll be finishing or winding up our session right here. Thank you.
Thanks,
Thank
sir.
you.
Thank you so much.
Thank you.
Thank you, bye.